Hi, this is the Technical Math 2 project from Humber College. We will be going over Chapter 20, Section 2.1, question number 14. We would also like to point out our copyright credit to Wiley & Sons Publishing for providing the homework question. This video is brought to you by Kurt Jurgen, Young Ho Oh, and Christina Liszczynski.
This topic is exponential decay. But what is exponential decay? It is when a quantity decreases so that the amount of decrease is proportional to the present amount. Ugh. Stop that. Ugh. But what? I'm never gonna do this? Why do I need to know this? There are many real-world applications for this.
For example, when a car passes you by, the sound does not instantly stop, but gradually decreases as the car is moving away from you. On to the question, are you ready? Question 14. A certain radioactive material loses its radioactivity at the rate of 2.5% per year. What fraction of its initial radioactivity will remain after 10 years? You might be saying, what? I don't get it. But don't worry, that is why we are here. First, the formula for exponential decay, which is y equals a times e to the power of negative n times t. A is the initial amount, e is the e button on your calculator, n is the rate of growth. In this case, the negative sign makes it a decay, and t is time. Also remember that in the equation, the time units of n and t must agree. In our case, both are in years, so it's okay. As we look back at the question, we can see that n and t are given, n being 2.5% per year and t being 10 years. Now you need to convert the 2.5% to decimals by dividing by 100, which gives 0.025. As a side note, to input e, you press the alpha button here and the ln button here. Now we plug in our values in the equation. Since it asks for the fraction of its initial amount, you can do so by dividing both sides by a. Doing this gives us a ratio of y to a, so no value is needed for a. And the answer is 0.779 of its initial amount. You get it now?
Let's do another example. Since there are 3 of us studying to be engineers, we'll try question number 11. A steel forging is 800 degrees Celsius above room temperature. If it cools exponentially at a rate of 2% per minute, how much will its temperature drop in an hour? Now let's see the hints we are given. We can see that 800 degrees Celsius is the initial temperature, so that is A, and it cools at a rate of 2% per minute, which we divide by 100 to get 0.02 as our n, and 1 hour is our t. But wait, our time value for n and t does not match. Don't worry, all you have to do is convert the unit of t to agree with the unit of n. There are 60 minutes in 1 hour, so our t value is 60. Now let's plug in our values. 800 times e to the power of negative 0.02 times 60 gives us 241, which is the temperature of the forge after an hour. But it asks for the change in temperature, so to do that we have to subtract the new temperature by the initial temperature. 800 minus 241 gives us 559 degrees Celsius as our final answer.
Now let's recap what we just learned. The formula for exponential decay is y equals a times e to the power of negative n times t. A is the initial amount, e is the e button on your calculator, the negative n is the rate of decay, and t is time. Remember that in the equation, the time units of n and t must agree. Here's an interesting fact. The e we keep inputting is an exponential function, which stands for Euler's number, a number approximately 2.718. Remember that math is universal, and it doesn't have to be hard. Just keep trying. For more examples, try questions number 12 and 17, and if you're ever stuck, don't hesitate to go to the Math Center for help. No appointments needed. Other sources are Khan Academy. A link is provided below. Thanks for watching our video.
Created using Powtoon.